Hello and welcome to the following episode. So on this one, we're gonna learn how to fetch an URL and get the data of it and display it. So it makes for me more sense than the previous one, the Lissajou one, because in the tooling world, fetching an URL is quite often happening, or you probably have to do that quite often. So it has more sense. So here, to illustrate the minimum necessary to retrieve information over HTTP, there is a SAM program called fetch that fetches the content of each specified URL and print it in uninterpreted text. It's inspired by the invaluable utility curl. So yeah, if you don't know curl yet, curl is just actually getting the content of a website. So for example, let's say google.fr, then it will just display the content of it. So here it's a 301 moved because I didn't put. Oh, I did put it, but they move you on www.google.fr. This one moved to. Well, anyway, so this is the same thing. We're gonna do the same thing. VS Code. Okay. So one tutorial was already written anyway. So let's create a new one called fetch, as I said. Let's go. And this one is supposed to fetch a website. So package main, of course. Fetch.go. Unable to write. What? Oh. Fetch.go. Better package main. Yeah, install if you want. Error. Go get. Alright, this is done. So func main, as always, it's a program for URL. We're gonna take the arguments, not the first one, but after the first one. Toc, and then resp. So resp for response, error for error, HTTP get URL. Right? If there is not nil, then fprintf ostdr, so standard error. We're gonna print fetch v r. Alright, we display that we got a problem while trying to fetch. And then we continue because this one is not opening, so we go to the next one. Oh no, they exit if we encounter any problem to get. So let's exit this time. And then if we succeed to get the content, then we will read the data with read all resp body. Right? Same thing. If r is not nil, then I display an error on the stdr output saying fetch reading s reading s v backslash. Okay, so URL r to display that we got an error, and then we exit again. That's weird because it's not because the first one doesn't work that the second one couldn't work. But anyway, let's just follow the tutorial here. here it is, we got it. So now let's go run it. Go run fetch, no arguments, nothing happens. Then https www.google.com, or was it y? Yeah, maybe y. Up, google.com, and then it displays the content. So I was actually writing google.fr, so that's probably why I was moved to google.com. But now, if I curl, I have exactly the same thing, as you can see. It was exactly the same thing. So we kinda create curl, and what can I say about that? So we looping on the argument, so you already know this one. Then we try to get or we send a request to get to the URL, and we take the response and the error. If the error is not nil, it means that it didn't succeed to get this URL. We can make it happen by, for example, creating a fake one, and then it's curl. Let's say random one, and then DLTCP lookup, no such host. So we got a fetch on this get. We got an error on this get. And then trying to read the content of it, and either it puts the content inside B for body, I guess, or error, R for error. So if it didn't succeed to read for any reasons the content of the response, then it returns an error and indexes it. And if no problem, then we just print. So you can give more than one argument, so more website, and it will do the same with all the website. So that's really almost everything you need to know for this one. And yes, that's what they explain in the following. So okay, then we go directly to an exercise now. This one was short. Exercise 1.7. The function called io copy dest src reads from src and writes to dest. Use it instead of io util read all to copy the response body to OSSTD-out without requiring a buffer large enough to hold the entire stream. Be sure to check the error results of IO copy. Okay. For this one, I think they want us to just avoid having to do that and just print directly to just let's comment that for the moment, keep it here. So what they want me to do is to use IO copy. So IO copy is taking a dest writer, so the destination gonna be my std out, and the source is my res body. Okay, and as you can see, it returns either written or either error. So written is not useful here because I don't need to know what has been written or not. So what does it answer? Let me just check. I think it just returns how many characters have been copied. Copy. Okay, can you walk? Oh yeah, for sure. Nil, not ROF, because copy is defined written, implement. Let's just go check that. Copy buffer, des source nil, and this return return int, yes. Return read from, right to. Well, just don't go too deep inside this, but we don't need this. But we need to check the error. So let's do that. If r is not nil, then we can just copy that. Turkey. And then we can remove this. Okay, a problem here. No new variable on the left. Ah, of course, because error is already created here, and I'm not assigning to the first one, so I need to write this way. Okay, go run, and now let's do it again. There it is. It works with just io.copy. Exercise 1.8. Exercise 1.8. Modify fetch to add the prefix HTTP to each argument URL if it's missing. You might want to use string as prefix. So modify fetch to add the prefix HTTP to each argument URL if it is missing. You might want to use strings as prefix. Okay. Oops. Let's see how strings as prefix work. Could have used also the same way I read for copy, but let's try another method. As prefix, then as prefix, an example here, println as suffix amigo, go. Okay. So just let's do that then. Okay, so we're gonna check this here before trying to get. So if strings as prefix HTTP, so if not as prefix, then we can just do URL equal HTTP plus URL. I think we can do this way. Not enough argument in call as prefix string. What was that? Oh yeah, of course. I need to specify what. So if URL as HTTP front of it. So if not, we add it, and then we get code goes. So now if I just type google.com, it keeps working. Great. Exercise 1.9. Modify fetch to also print the HTTP status code found in RESP status. So exercise 1.9. Modify fetch to also print the HTTP status code found in RESP status. Okay. Let's write it here because we don't need to read the body first. fmt print ln. Just go with printf. Yes. Yes. I'm gonna print the rest. Maybe it's not a string, so I'm gonna have to change it, but rep status is a string. Okay, so all is good. Let's try again. So 200 OK http google.com. Oh, I should have added also a return line, even maybe two, just to make it clear. And then 200 OK, http://google.com, and the body. So it is, we are done with this one. It was quite short. So just let's continue. The following section is actually about doing fetch concurrently. So it has sense to keep it on this video. So one of the most interesting and novel aspects of Go is its support for concurrent programming. This is a large topic to which Chapter 8 and Chapter 9 are devoted, so we will see later. So for now, we will give you just a taste of Go main concurrency mechanism, Go routine, and channel. The next program, fetch all, does the same fetch of a URL content as the previous one, but it fetches many URL all concurrently, so the process will take no longer than the longest fetch, rather than the sum of all the fetch times. The version of fetch all discards the response, but reports the size and elapsed time for each one. So let's go to the code of this one. Fetch all the Go. Okay, package main, as always, we're creating the program here. Func main, so we are gonna calculate the time took to fetch the page. So we are doing the same thing than one of the first video. So channel, we create channel. So channel is quite special, and I'm not sure what it is exactly. So maybe keep it for the following. We would have a huge chapter about that. And for the moment, just go straight and use what they ask me to use. Range OS arc, same thing, we're reading all the arguments, and for all of them we go fetch. And the fact that we put go front of the function means we want this to be run concurrently. And then it is. It's gonna be done this way. And now for range OS arcs 1 fmt println channel. So we send to the channel how it is. Oh no, we are reading the channel. So we wait for a return from the channel. They wrote receive from channel ch. Yeah, from channel we are waiting that they send something and then we print it, from what I remember. So it is fmp printf, then .2 fs. So it's to print the second elapsed to get the content. Time since starts in seconds. Alright. So now I will have to write the fetch function. Okay. Func fetch. It was URL and channel. So URL is a string, channel is a channel. It's probably this way, let me check. Oh, no, channel chan. String. Okay. So now, same, we calculate time, start time now, resp r http get URL, if r is not equal to nil, then channel fmt sprint r. So we send to channel a string with the error. So it's generated so that send to channel ch and then return. So we return the function. N bytes r io copy. So we're gonna read how many bytes we read. io till discard resp poly resp body close. Okay. If R is not equal to nil, then channel fmt is printf. While reading S, so we got an error while reading S, and the error is this one. Okay, then we return, same thing, 6 time since start seconds, right? And then we send to the channel how many bytes we read, probably s.f, yes, 2.f, 2f, seconde, 1, 2, 7d, 1, 2, s. So we print the sex, the number of bytes read, and the URL. Okay. So for good, let's compile it now. Go run fetch all google.com. Oh no, we don't have the asmfix written, so let's write them correctly. Google.com quant fr, and then as you can see, it has taken 51 seconds to fetch google.com, 0.54 seconds to get quant.fr, and then it displays the time elapsed for fetching all of them. So what I can explain. So just here, as you know, the goal is to say that this function is run concurrently. So I'm not waiting the return of this one to continue to loop. So it's gonna just send fetch. It's just gonna get asked to fetch, and then for all of them without waiting the return value. And that's why we're using a channel here. Channel is waiting for messages, and then when we receive messages, we just print them. So that's why inside the channel, so we send the channel in arguments, and as you can see here, for all the value that we have in, so it's gonna loop on how many arguments we have. So here it's just gonna print channel. For example, here we just gave 2 URLs, so it just wait for 2 return value of the channel. So it's, and the order doesn't matter. The first one will come, the first one will be printed. So let's see if it does it again. So quant, it seems to be a little bit slower. So let's put quant.fr first and google.com after that. Google.com. As you can see, even if google.com was the last one, it comes back the first one, because the channel is just printing what it receives. And like we send them concurrently, so almost at the same time, then the fetch URL return will print inside the channel to the first one. We'll send to the channel the return, and the channel is just print here. So that's how concurrency working, and it's quite useful. So let's just continue now. They probably asked me to do some exercise, or maybe not. No, there is 2 exercises. So now, find a website that produces a large amount of data. Investigate caching by running fetch out twice in a succession to see whether the report time changed much. Do you get content each time? Modify fetch all to print its output to file. So as you can see, we already noticed that. The first time I fetch google.com, it takes 51 seconds, and the second time it takes only 0.15 seconds, because they probably catch the answer and send it back to me. And yeah, once again, it's coming faster, but as you can see, it seems that quant is not catching at all, and it's just printing, it's just taking time every time I run it. So this exercise is already done. Try fetch all with longer argument list such as sample from the top million website available, alexa.com. How does the program behave if a website just doesn't respond? Describe mechanism. Let's go to alexa.com. I don't know this website. Okay. What the fuck is that? Wait. Try fetch with long argument list such a sample from the top million website. Okay. I have no idea what they ask me to do on this website. I'm supposed to get top millions website. Alexa. Okay. They want me to copy all of that. I'm gonna use sublime text. I'm more used to the command line. Dot C. Let's just do this way. Okay. So it seems I have stopped the video by mistake. I cannot use my command line because it's stopping the video. Right. I think I'm just gonna skip this exercise for now. It's not important, and what they asked me, try to fetch and does the program behave if a website just doesn't respond. So how the program will behave if a website is not responding? It will wait until it responds, and if it doesn't, I will get a timeout at some point on my HTTP connection. So it's gonna probably wait for a few times, and if it doesn't get the results back, it's just gonna give me back the prompt and say that the website timed out or the connection timed out. That's all. Thank you.